Recording, we are going to talk about angle properties. So we can also call this topic the geometry toolkit, because everything we're going to learn here is going to help us too much in the other topics in geometry. So let's get started with the names of angles. So we have an acute angle when the angle measures between 0 degree and 90 degrees. We call this angle acute angle. When the angle exactly measures 90 degree, we call this angle right angle. So when the angles measures between 90 and 180 degrees, we call this angle obtuse angles. And whenever the angle measures more than 180 degree, we call this reflex angle. So we have four types of angle: acute angle, the angle between 0 and 90, right angle, the angle precisely 90 degree, obtuse angle, the angle basically between 90 and 180, and the reflex angle, the angle greater than 180 degree. So let's get started with the names of triangle. So we have equilateral triangle when the triangle got all sides same. We call this triangle equilateral triangle. We have an isosceles triangle when the two sides of the triangle are same. We call this triangle, we call this type of triangle an isosceles triangle. So when the triangle got 90 degree, we call this triangle right angled triangle. One of the angle of triangle is 90 degree. We call this right angled triangle. So we can have isosceles right angled triangle as well. So when the legs of the right triangle are same, and of course one of the angle measured 90. So this is called right angled isosceles. And we have a scalene triangle, so none of the sides of the triangle are same. We call this a scalene triangle. So angle properties. So we have angles on a straight line. So angle on a straight line add up 180 degrees. So we have an angle at the point. So angles at the point add up to 360 degrees, one complete rotation. So we have here one complete turn. So all of these angles add up to 360. And we have a vertically opposite angles, so where the vertically opposite angles going to be same. So angle A will be the same as angle B. So let's have a look at angle properties in a triangle. So we do know that the sum of the interior angles of triangle add up to 180 degrees. And the second property here we have for the triangle is the sum of the two opposite interior angle is just equals to the one exterior angle. So sum of the opposite interior angles to this exterior angle is the sum of these two will be the same as this exterior angle on the triangle. So A plus B will be the same as C. You can write down this property for the other angle, for example. So whatever the angle over here is, so that angle plus A will be the same as the one exterior angle we have over here. And you can say the same one exterior angle that we have over here as well. So the sum of B plus whatever the angle over here is will be the same as this one. So, and the angles in a quadrilateral. So we do need to know that the angles in a quadrilateral add up to 360 degree interior angles, as well as the exterior, some of the exterior angle in a quadrilateral add up to 360 degree. So before we move on to the next slide, I just want to point out as also some of the exterior angle in the triangle is also 360 degree. Exterior angles in a triangle are 360 degree. So parallel and perpendicular lines, we do know that. So if two lines parallel, they will never meet. Okay. Okay, so this line parallel to this one, so that means they will never meet, they will never intersect. So at the perpendicular lines, obviously the lines at the point of intersection, they intersect at perfectly 90 degree. So at the point of intersection, they intersect at 90 degree. So let's look at some properties of a parallel line, the angle properties. So in the parallel line, obviously these two lines are parallel, as they mentioned over here. So we have angle called corresponding angle. So the A over here corresponding to B. So that angle over here, so I'm just pointing with the laser, will be the same as with this one because they are corresponding just like that. And you can basically find out few more corresponding angles we have here, such as the angle I'm pointing over here will be the same as over here. They are corresponding. So the corresponding angle will be same. And we have the alternate angle. So we then remember that alternate angle using the Z shape, as it looks like a Z. It looks like a Z. And by the way, the corresponding angle you can remember from the F shape. Okay, so the alternate angles also same, and we do have a couple of alternate angles here. So A alternate to B, as well as that angle, whatever the angle over here is, will be the alternate to this. Actually, we have two alternate angles here. Okay, so interior angles, so the angles are located sort of inside, and or sometimes called the one-sided interior angles. So the sum of those in one-sided interior angles will be 180 degrees. So those are so very, 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 very important properties that you need to know. So because we're gonna use them in the circles and any quadrilateral, like the question, and as well as complicated parallel line questions that you need to know very well in order to solve that problems. So let's have a look at one example. So we are asked to find out the size of each lettered angle. So that means we need to find what is A, we need to find what is C, we need to find what is B. So obviously we do know that the A vertically opposite to 127 degrees. That means the size of A will be 127 degrees, as they are vertically opposite. We have to give a reason for this as well, because the question tells, okay, find out calculate the angle, for example, B or C, whatever in the question, on the past papers, on the question paper, exam paper, that you need to give a reason. And the reason is not a calculation. Reason is the mathematical thing that you need to write why this is this. Why A equals to 127 degrees, just giving a reason that they're opposite angles, vertically opposite angles. So, and we do know that, so the line over here is a straight line, and the A plus B will be 180 degrees. So because it's the angle on the straight line, just we did on the first slide, I guess. So you can use that, since we know what is A, to find out B, and if we do know B, we'll be able to find C because they are also vertically opposite angles. So as just mentioned, A plus B will be 180 degrees. So A plus 127 will be 180, then B will be 53. If B is 53 degrees, that means C will be 53 degrees as well. So let's have a look at one more example. So here we have a triangle, but this triangle is not an ordinary triangle. So we do need to know that the meaning of these two lines, they basically sketched over here. So I'm talking about this little line segment. So if they mention this little line segment, that means this side of that triangle, this side of that triangle will be the same as this, as they mentioned this two little line segment on these lines, on these sides. So that means this triangle is an isosceles triangle. So therefore, the angles at the base will be the same. So we do know one, that means other will be 72 degrees as well. So A will be 72 degrees as it is an isosceles triangle. So after finding A is 72 degrees, we'll be able to find the B just using the sum of the interior angle property for the triangle. We already said the sum of the interior angles of a triangle add up to 180 degrees. So that means A plus B plus 72 will give us 180 degrees. We already know what is A, so we're going to substitute it over here. And the A is 72 and plus 72 will be 144. And B plus 144 equals to 180. That means B will be 36 degrees. So we found A and B as they asked like. So now let's have a look at one more example. This example basically assessed the angle property that we know from the quadrilaterals. So we said that the sum of the interior angle of a quadrilaterals add up to 360 degrees. So that means if I add A 202 plus 143 and plus 61 will give me 360 degrees. So then I'm going to calculate this simply, and I'm going to just add 61 plus 143 plus 102, and then I'm going to do subtraction, subtracting 360 from 306 from both sides, and I found that A equals to 54 degrees. So the size of A will be 54 degrees. So now we're going to look at the example that basically assessing the parallel line, angle properties on the parallel line. So we do know that the angle A is the corresponding angle to 128 degrees. And we said that, so if the angles are corresponding, they are same. So that means A will be 128 degrees. So one more example regarding the parallel lines. So what do we know? We do know that the one-sided interior angles add up to 180 degrees. So that means A plus 131 degrees will be 180 degrees. On a parallel line, we do know this property. So then we're going to subtract 131 from both sides, and we'll have A equals to 49. So one more example. So we do know that angle A is alternate to angle 132 degrees. So when we basically just realize they are alternate, we can take them equal. As we said, the alternate angles are same. So that's it.